redo it. Like I gotta remake it.
Right.
Yeah.
You gotta remake the whole thing.
Alright, so it's an integral of 4 minus 4x cubed
I watched that on some yesterday.
plus x squared all over x to the 4th minus 2x cubed. And then they put the 4x cubed plus x squared on the top in parentheses, so that might be like a clue.
Yeah, because the
Which
minus
one?
would be
Which is in
distributed.
parentheses, this?
Everything but the 4.
4x cubed
the
minus plus x
numerator.
squared.
With the minus out in front?
Yeah. Oh, yeah.
Okay, what problem number is this?
This, I think it's 6.
Yeah, I don't know, the parentheses don't help one bit at all.
Just distributes the minus.
Well, let's go ahead and distribute the minus, I guess, I can do that later. You do want to check if this is a Udu substitution integral. So the derivative of the bottom would give us a 4x cubed, but it would also give us a minus 6x squared. And we don't have a minus 6x squared. So that doesn't really, it's not a Udu integral. So if it's not a Udu integral, you got polynomials here and here. What's the plan? Partial fractions, whether we knew it was in this section or not. The degree on the bottom is bigger than the degree on top, so it's in reduced form. All we need to do is see if we can figure out how to factor this. So I'm gonna write this integral without the minus sign. I'm gonna distribute it. And then we're gonna factor the bottom. It's got a common factor of x cubed. And then, so the other factor is x minus 2. So that says we should be able to break this up into how many pieces? 4 pieces. We'll have a something over x, something over x squared, then over x cubed. That's our repeated factor rule. And then we have something over x minus 2. So let's figure out all those things. Let's see how far over I can go. I can do here. So let's do it right here. Do the partial fraction decomposition of that. Set that equal to a over x plus b over x squared plus c over x cubed plus d over x minus 2. Those are all considered linear factors. So we just used a, b, c, and d.
Is there, I thought there was something where it's like, if it was like a squared on the bottom, you had like an X on the top.
That's if it were, see, I don't consider this a second degree factor. I consider it to be a repeated factor of the linear factor x.
Okay.
So, but if it was like x squared plus 1, it would, the top would have to be,
Right.
be x squared.
Right.
Okay. Okay.
Okay, so when we cross multiply here, can you tell me what cancels? What's the a going to be multiplied by?
X squared, X cubed, and X minus 2.
Just, you got a little more than I want. Here's what you're canceling in your head.
So it'd be an x times x minus 2.
Be an x squared
X, I mean,
times an x minus 2. What about the b?
It's gonna be bx times x minus 2.
Okay. And the c?
C times x minus 2.
And the d?
X cubed.
Okay. I think we can get to the variables by substitution. The other ones we might have to do a little work.
You guys go to
Have no rag.
A 0, do the same thing.
oh no, you have to do the next.
Oh, no, get C. Yeah.
Yeah,
it's-
let's see.
Yeah.
What happened to my little board eraser?
I got a question.
Yes, sir.
So in the like that cancellation, Where does that take place? That did not happen in my head.
This part, I'm taking each of these and multiplying them by x cubed times x minus 2.
Yes.
That's what I'm doing here, kind of in my head. And I multiply both sides by this and distribute through the right-hand side.
Oh, I see where that is.
So this x cancels one of those and gives me an x squared, leaves that factor behind. 2 of these will cancel, so I get a first degree with the x minus 2. All 3 of these cancel, so it just leaves me c times x minus 2. And then the x minus 2s cancel here.
The two-sided view. Right, but you've got there's another side.
I don't have a rag to erase my board. Why? Oh, found it. Okay, so let's get some real quick. Let's do the x is 0. X is 0 is going to give us c. Put 0 in for every x. Over here, I'm left with 4. That'll be gone, gone. -2 times c, and then d is gone. So I get c is equal to -2. What's the other quickie?
X equals 2.
All right, so let's let x equal 2 everywhere. So I have 4 minus 4 times 8 minus 2 squared is 4. And over here, that factor is gone, 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 and I get d times 8. So this 4 minus 4 is 0, -4 times 8 is a -32. So d is equal to -4.
I got that too.
Yeah.
But really, there's nothing else that I can do. We still need 2 more variables, so I'm gonna need 2 equations somewhere. Any suggestions?
A plus b equals -4.
Okay, so A and D are the only ones that have an x cubed on them. So we can kind of equate coefficients where we see fit. This is gonna be an x cubed. This is gonna be the other x cubed, and none of those other terms will be an x to the 3rd power. So those x cubes have to be this x cubed.
And D is already -4, so.
That's right. So we equate coefficients of x cubed is what we're using here. And on the left, we have a -4. And on the right, we will have a plus d. And d is -4. So a is 0?
Yes.
Okay, now we still need another one.
-2a plus b equals -1.
Okay, so you're doing the x squareds? Looks like it. This will give you an x squared term, and this will give you an x squared terms. There's no x squared terms here. So the x squared over here is a -1. And over here, we said it was going to be -2a plus b. A was 0. So b is -1. Now we got all 4 of them. This was 0. This is -1. C is -2. D is -4. This one's gone. So what we're integrating are with power rules here. We're going to integrate -x to the -2, -2, x to the -3. And then this will be a logarithm. Right? excuse me. Add 1 to that and I get a -1, divide by -1 and it cancels there. So I just get x to the -1. Add 1 to that gives me -2, divide by -2 gives me a +1 in front. So plus x to the -2, and this is 4 times the natural log of x minus 2. You like the 1 over x and the 1 over x squared better, you can do that. Okay,
Thank you.
you're welcome. You have your homework problems you want me to work? Then I-
The negative 2x cubed.
Let's see, when you add 1 to the power, you get a -2 here. And so that's gonna be divided by that -2.
Oh, okay, I see.
You guys find the web work you needed to do? Everybody? All right, well then let's go back and do some of this sheet. You've got your integral worksheet on you. If not, I've got a few extra copies if you need another copy.
No, I'll just write that what she says.
So which ones, have you done the first 3, everybody?
Yes.
All right, we'll put down the answers to the first 3. Check 'em. Let's see, the first one should just be 2 times the natural log of x minus 3. Second one will be 2 times the natural log of x minus 3. Let's see, that's going to be -5 over x minus 3. Plus 1 over 2 times x minus 3 squared. Yes, no, maybe?
I'm just wanna do that one.
Did or did not do that
I
one?
have not done that one yet. I just haven't had time.
Then
to
don't
do it.
peek.
Okay.
And then the third one. Minus cosine cubed of x over 3. Has anybody worked number 4 yet? You got it? Then everybody else work number 4 for me. You guys are getting?
Yep.
I got 10 over the square root of 2 times all that.
You got more?
Yeah.
I got
You got
that.
more.
Oh, that was just an arc sum substitution.
No.
It's a plus. And there's a
Yeah.
plus under the radical sign. What do we substitute?
Tangent.
Tangent. X is gonna be the tangent.
You work that out for us.
I can. Do you want to work it? Why not?
Because I'm not finished.
We're among friends. Watch you, I'll help you, I'll poke you and prod you. Maybe it's not big enough for folks watching at home to see.
I have a question.
I'm gonna go.
Talking is good.
Yeah, so our tan, I mean the tan. So X is equal to A, which is 2, right?
Right?
2 tangent theta, and then dx is equal to 2 secant squared. Right?
D theta.
D theta.
Marvelous.
And then I took out 5, is that okay?
Take out the 5 is good.
So 5 integral, that was ugly.
Yeah, you need help on that
over-
integral.
I know.
That's okay. We're not,
At
least
brave
you
enough to do this.
X squared, which is 4 tangent squared of theta plus 4. And then
Whoa, back up. Where's the dx? Okay.
there we go. Okay, and then
Oh, that's better.
okay, and then you factor out the 4 from the square root sign.
Okay.
Okay, and then
Is it a plus one?
It's plus.
It is a plus 1. There you go.
And then from here, you take out the 4, right? And then you make it a 2, and then you can have
That'll work.
here. So 5 halves. Should I take out the 2?
Sure.
So 10? Which is
You
5.
can just, yeah.
Okay, and then we have the secant squared theta over, we took out the 2, so it's secant.
Secant squared is the 10
Yeah,
squared
and then-
plus 1, and then the
Yeah.
square root of that is the secant. Okay,
And then we take 1 out, so we're left with secant theta.
and
5
integrate secant of theta. And that's the whole
And
formula.
that's the natural log. First 5 times the natural log of secant, or the absolute value secant plus tangent.
Theta plus tan theta. All right,
And then now we go back here, right? And then
Yep.
solve for x. So, we have tangent theta is equal to x over 2,
okay,
which is, opposite of it, isn't it?
Yep.
So, my triangle, that's ugly. So opposite is x, adjacent is 2, which would make the hypotenuse x squared plus 4.
Yep.
And then, theta is the,
we don't need theta, we need secant of theta and tangent of theta.
okay. So secant theta is 1 over cosine, which is, hypotenuse over,
I always go, how? Like that's how my brain thinks.
mm,
If instead of oh, like I go
oh,
like
And then tangent is going to be
That's really stupid, but
adjacent over opposite.
By the way, opposite over adjacent.
Oh, yeah. Tangent theta is equal to, oh, we already had it.
All right, go ahead and you're done.
there's some wrong tricks.
No more integral sign. Really black hands.
You know what it really is. So, moving seats mid-class.
Yes.
Why don't we use, that's a good idea.
We're just continuously moving around.
Yeah, that's spicy.
That would be with that minus sign in there. You must have miscopied that. That's a minus sign in front of the U squared is the arc sign.
Oh, so they're supposed to
A
be
squared
negative.
minus U squared. A squared minus U squared.
I'm good with that.
Yeah, that's another sign. That'll do it.
So to go square.
Everybody okay with that one?
Really like to just
Did anybody do
And I
number
might explode
6?
it.
Did you do number 6 by parts?
No, I don't know the question is.
No.
6.
UDU.
So- Oh, yeah.
Oh, I meant number 5. Number
Number
5.
six. Yeah, number 5 I did.
Did number
Number 6
5
I
by
did
parts, so the answer to number 5 was 1/2 x e to the 2x minus 1/4 e to the 2x. Using integration by parts. And then number 6 is strictly substitution. So number 6, your answer is you're integrating e to the u and you get e to the u, but you get a 1/2 from the du term. 1/2 e to the x squared plus c. All right. Number 7 is a known integral, except for you got a 3x in there, so you can be careful. So be real careful and give you a second to try number 7, and then I'll put the answer up here.
Square root of 3x, yeah. Actually, no, I don't.
Yeah.
Yep.
UDU substitution, then they're integrating sine squared of u. The du term gives you the 1/3. So you get u over 2 minus the sine of 2u over 4. And u was 3x.
Question.
Yes.
I think I know the answer to, but I just want to ask you for confirmation. So this formula, no matter what comes out front, will always work out to have that first term.
It's not wrong, so I'm just trying to see like.
U over 2.
Well, yeah, but.
This would be.
Well,
do you mean?
the thing is like
So
that.
it cancels with 1/3?
Yeah,
Yeah.
like that, so that first term is always going to be variable inside the integral. over
Right,
chunk.
right.
What'd you ask?
Any questions on 7?
That first term is always going to be x over 2.
Yes.
Would you still take it if I wrote it like
Worse and
this?
worse as far as the.
If I broke it up into.
Oh, that's fine. That's fine. So your x minus x over 2 is like
It's like any other
x
number
over 2.
I just did it. I don't know if I got it.
Sure.
Okay, I'll do my.
Okay, how did you do number 8?
Didn't.
I have
Do
not
it then.
yet.
Do number 8 real quick.
We should decompose our fractions.
That's
That's what I did. Or partial.
Oh, really? Yeah, I just did,
I don't think I should have done that.
partial fractions. Seemed easier.
Yeah.
Wait, how do you do partial?
Guess we'll see if I did it wrong.
Just go ahead.
Yeah.
Can you pull the 3 out?
You can.
That'll still work with the.
So are partial fractions if you just have a 1 up there.
Okay.
He's like, the distance. Really good spot.
So are you recognizing number 8 as partial fractions? And you can try to complete the square, but you get something you have to do partial fractions on anyway.
I did it as like a inverse trig function.
Whoa.
I
Why?
think it was art, I think, because it looks like arc sine to me, or like something like
There's
that. Like,
no pesky radical.
Yeah.
well, no, because I think, isn't like the integral of 1 over x squared plus a squared, like, not to be arc sine?
Yeah, but that, X is in the way.
You could complete the square and do it.
Wait, no.
But does it come out as an arctangent if you complete the square? I think
You can
it's
substitute it, you can complete.
it's gonna have a minus.
And then you use like.
I haven't done it.
It's gonna have a minus sign if you complete the square, which means you've got to do partial fractions.
You just try and cancel it.
Partial fractions.
Partial fractions is quick and easy, right?
So yes, it's that x equals 0.
Factor that denominator as an x times an x plus 4. Those are really easy integrals to do. You can do something over x plus something over x plus 4. You can do that a lot faster than trig sub, right? So if I just do the partial fractions real quick,
You get 1.
kind of done it 2 steps, right? You get a negative 3/4 natural log of x, positive 3/4. 3/4 natural log of x minus 3/4 natural log of x plus 4. But I think that if it were this problem here, I would do it differently. I would do that problem differently, maybe. No, I wouldn't.
No, you
It'd
wouldn't.
be easier.
I would think about completing the square, but I won't get a plus out here, will I? No, so I lied. I wouldn't do that differently.
I'm okay skipping that one for now.
Yes,
Did you say that if you were to pull out the 3 at the very beginning, it would still work.
It would still work, you just have this,
No.
you have the values be 1/4.
Yeah.
Would be your answer if you pulled out the 3 at the beginning.
I think that's when you have the integral with like sine x cosine.
I would definitely reserve the trig substitutions for things that all the other methods fail, because that's the one that takes so long. It's not nasty, it's just long.
Hurts my feelings.
So if you're hankering for trig substitutions, you can try number 10. Anybody work number 10 yet? Have you done number 9?
I've done 9.
And let me check your answer on number 9. Integration by parts on number 9. 2x over 3 times the sine of 3x plus 2 over 9 times the cosine of 3x.
I didn't do that.
Get it, got it? If you haven't done it, do it real quick. It's integration by parts. Here's the answer to number 10 for those of you who've done it.
We want you to be the cosine of 3x.
Do you?
For the integration by parts? No. Not if it's a polynomial times a trig. You go u with the polynomial term. Number 10, we get kind of a big old answer. I'm sure it can be simplified a little bit better than I did it. Are those two, if you need help, let me know.
You do the pesky radical and then it's
Number 10, you definitely do a trig sub. Which trig sub would you do? If the x squared is behind the minus sign.
you can
Other one, sine, right? 1 minus sine squared is cosine squared, so you do a sine. And since that number is not a perfect square there, you'll have to use the square root of 5 times the sine. And it looks like you get, oh, I bet somebody needs to work this one for me. Somebody's probably gonna need to work number 10.
Wait,
I think I can do it.
I
I
just did
gotcha.
it, but.
You wanna come do it on the board?
Yeah, wait, let me just see what I did. I just like a week ago, or whenever we did
Well,
this.
this is so-
A week
this will be
ago,
kind of
whenever
like
it was.
studying,
It feels like a
right?
week
You do it
ago.
without looking. If you
Is
do
that
it
right?
without looking, then you've studied it enough.
Is that what you got,
Do it
Darby?
without looking.
looking.
Okay, all right, I think I got it.
Is that what you got, Darby?
But yeah, I did all the steps, right? I'm pretty sure I just like
All right,
wrote down
let's
my
see-
final
Let's
answer,
try
something
to
really
right
weird.
over here.
Okay. All right.
All right, we're gonna work number 10 all the way out.
Forgot what it was.
It was the integral of the square root of 5 minus x squared
5 minus x squared.
dx.
Okay, dx.
That is the largest integral sign I've seen today.
I draw my integrals big. Gotta do it. Okay, so this one looks like trig substitution to me.
That's the pesky radical. And there's not a UDU. You always look for a UDU first.
Okay, so then I can take this is a squared, and then we have u squared right here. So then we're gonna take x to be, all right, so it's a squared minus u squared, which means it's gonna be sine. And then that means x equals the square root of 5 times the sine of
Okay,
theta.
pull off this camera. You have to come back
Oh, my
over
bad.
here so that you're on camera.
Oh, there we go, okay. Okay, right again over here. We have x equals the square root of 5 sine
We haven't
theta.
called it anybody, we can make fun of their handwriting.
You guys are doing great. My handwriting is beautiful.
Mine's definitely not.
I bury all this one up here. The square root of 5 times the root of sine, which is gonna be cosine theta, d theta, whoops. Okay, so then we can sub it out. So we have the integral of the square root of 5 squared minus the square root of 5 sine theta squared, and then subs out dx, multiply that by the square root of 5 cosine theta d theta. Okay, and then solve that. So it's gonna be, rewrite this. 5, it's gonna be 5 minus 5 sine squared theta times square root of 5 cosine theta d theta. Then take out the 5. 5 times take out square root of 5 times the integral of this is cosine squared theta. So it's just going to simplify to cosine theta times the square root of 5 cosine theta d theta. And then I'm going to bring this out to the front. So just get 5. So then it's 5 times the integral of cosine squared theta d
I
theta.
did that, I wouldn't be able to get back up. You would have to come help me.
Okay, I don't feel like going lower than that, so I'm gonna bring it up here. So we have 5, break out the formula, so 5 times theta over 2. Ooh, what is that? Theta over 2 plus sine of 2 theta over 4. Plus b. Okay, then we gotta solve for theta. So draw a triangle. I have angle theta right here. Then we have x equals square root of 5 sine theta. So x over the square root of 5 equals sine theta equals the opposite over the hypotenuse. So our opposite side is going to be x, and the hypotenuse is going to be the square root of 5. So then the adjacent side is going to be
5 minus x.
5 minus x squared, thank you. And then, oh, and then we're gonna change this to an identity. So it's gonna be 2 sine theta, cosine theta. And we can figure out sine theta and cosine theta from the triangle. So we 5 times theta is gonna be arc sine x over 5. Into the square root of 5. This one's big, all over 2 plus 2 times adjacent over hypotenuse. And I don't have any more room instead. And then x over square root of 5. What did I do? That's very small. Okay. All over 4.
That's essentially it.
Yeah.
You're good. Plus a C.
There you go, Jack.
And so I canceled one of the 2s and the 4, and I wrote bigger.
Closure print.
Yeah, so that's the same answer.
Most important.
Thank you. Very good. Any questions on that one?
Wait, actually, oh
Let's
yeah,
go back.
and the 2's canceled. Never mind.
Close your parentheses.
There you go.
Thank you.
It's not hard to find a computer science major in the class.
I'm not. I'm civil engineering. Thank you very
Oh.
much.
Never.
Do you want me to erase it?
No, you're good. Thank you.
That's slappy.
So 9 was your basic integration by parts. Number 10 had the pesky radical sign. So you did the trig sub. Is there a number 11 on the same page?
So far.
So 11 was, who did it? How'd you do number 11? That's just a UDU. Take U to be x squared minus 25, and DU is going to be the top. So it's going to integrate a 1 over U du. So the answer to number 11 is going to be the natural log of U, which was x squared minus 25, but when you let U be x squared minus 25, the derivative is a 2x, so you get a 1/2 there. Next side. Ooh, this one goes circular. So I want to do it. Good.
I know, yeah.
Good. Try number 12 carefully. You got constants that you can't live with. This integration by parts, it's going to go back to the original problem. So those are the ones I called circular integration by parts. But you got to be real careful with your 2 and your 5 and your minus signs and all that.
It doesn't matter which one you do for you.
It absolutely doesn't matter which one you use as U and which one's DV.
I think I have it exactly answered.
Let me get my answer, because that one I can't do in my head.
Oh, you can't?
What are the ones that you can do in your head?
It's about all of them.
You have to sort out.
All right, let's see. That's how you simplify it. So you get a -5,
So it's a
only
W.
29, 2x plus 5x,
Z.
plus 2 over 20. 2x sine of 5x, fantastic. And you did it right there in that little bitty, sheesh. That's pretty good. Let's check the other ones.
I don't wanna do it either. No one wants to.
Then you're on 17.
You gotta do it.
You get 3.
Just you integrate. Well, it depends what's gonna be. What if you set W to 5x? Get a sine of U. What happens? Just line up on the rim.
It's so not gonna put it Oh, well. You're gonna have to get microscopic handwriting.
Yeah, just a minute.
I'm sure that's when we're gonna need somebody to work on the board with neat handwriting.
That's not me.
That's not me.
Does anyone look in the class?
Hey, if you don't want to read it, I'm.
What are we, handwriting majors?
I'm like, I'm like borderline.
You're working on your tutoring skills so that you could work as a peer tutor next semester.
Mm-mm. So do you get paid if you're a peer tutor?
Sure. You
How
make
much?
massive amounts of money.
Define me, tutor.
Those peer tutors are the ones that are driving those Maseratis around campus.
Oh.
And the rest of you are lime scootering it.
Hey, man, sometimes.
Wait, are they the ones driving it on the sidewalks?
Yeah.
To their classes.
I did it really. You were like.
Wait, actually, how much do you get paid?
How much do I get paid?
No, the.
Depends on how many steps I put in. If I put more steps in, I get like 75 cents per step.
So you're like Charles Dickens.
I'm like Charles Dickens. I'm missing the joke.
He was paid by the word,
By the
so that's why
words?
all his books were really wordy.
I feel like I'd be really good at the job.
And who's the
I'm-
guy that never ends a sentence?
What, the guy that wrote Les
Is it
Mis.
Hemingway? Never ends a sentence?
I have no idea. I
That
don't read
sounds
books because I'm a.
I'm pretty
I'm a
sure it's the guy that
physics
wrote
major.
Les Mis.
I mean, that's just called efficiency if you can do it all.
Maybe I lost the 3. Let me see what the 3.
The great
Entire book in a sentence. Good for you.
Let's see, that one is number,
You just take the derivative of what I have, you get that.
oh, look at you. See where I lost the 3 then? I'm looking for number 20. Okay, if you use the natural log of 3, UD is just 1 over x. So we're integrating 1/2 sine of u. 1/2 cosine of u. Yeah, I don't get the
But
3
no, if you use natural log 3x, du is going to be 1 over 3x.
times 3.
You do something.
In the novel, The Rotters Club, it says
Cancel.
with 13,955
Which one's negative, the derivatives cosine?
No, yeah, there are no questions.
Terrible, okay.
You wanna read, do you wanna hear the longest sentence in the world in a novel?
Sentence in the world? Sure.
It's 13,955 words.
Are you gonna read it to me?
No. Unless you pay me by the word. Don't pay me by the sentence, I won't take it.
Okay, fine.
That's a great find.
It's really.
Any volunteers? Wanna do it on the board?
I'll do
Will
it.
you take my answer?
Yeah.
If I got the
gotta
answer, if I
wait
got it
till
right,
I
then I will, but if it's wrong, I'm not going up there.
This is the original
I know,
integral.
like, I
After I
don't
do it 2 times, then I get this integral, so I have.
I regret that, actually.
Somebody was gonna tell you, there's a pencil in your head. All right, you guys keep working, but she's gonna put all the steps up here.
I didn't want to.
You have enough time.
Are you done? Write it down, start working. You don't have to either.
You're doing it to the test and just leave that one blank.
You're doing it.
I know how to do it.
I got 4/5 times 1/2.
That's
Oh,
fine.
sorry, by 27.
This is the movie.
I don't really think anybody like actually enjoys this.
To be honest.
The circular.
I think it's cool.
Yeah.
I think it's cool, I think it's cool, but it sucks at the very end, because you're like, oh man, if I get one number wrong.
Me too, the time I get it right.
That's life in general.
I like
It's
one
not
on the front,
necessarily.
two on the front, see which one.
I mean,
No, a
your
rocket will still
taxes
fly if the
for-
wire's loose, you know. Hopefully,
A lot of planes, is that what you said?
I said a rocket.
No.
Planes are a better example.
You'd be
Yeah.
surprised.
Okay,
The biggest non-nuclear explosion was a rocket. The
No, I
reason
think-
it exploded was because a guy hammered in the accelerometer upside down. When it just like
Oh.
slides in normally.
Hmm,
Why?
get my writing out of your way.
actually crazy.
That's terrible.
Those darn Russians, and Russians don't believe in
Don't
abort
mess up your
systems.
handwriting, you're doing great.
They just let the
Too
rocket
small.
fly in.
I don't think so.
So they didn't blow it up or anything like.
I can
that.
still
So
read it.
Hit the ground and shattered a bunch of windows. It's pretty insane.
Those Russians.
From space is parachuted deploy and like got like.
Then all you gotta do
I don't
is.
remember what it was. I
The
looked at
Russians?
Decide.
Yeah, the Russians.
They used to multiply their capsules. So that capsules still have parachutes, so they have to pop out. They have to attach.
Yeah, that's the.
It's really
Yeah,
difficult
something the
to
plane can do, but.
Because putting a parachute on the rocket's kind of complicated.
Yeah, but I don't remember what it was, but it was some like crazy malfunction.
Well, there was one malfunction where well, Russians didn't have spacesuits, pressure suits, because their vehicle was too small for them. They had the craft. So, there's leaking of the doors.
You scared me.
Just write it between the lines.
Okay,
You got it.
yeah.
Yeah, there's-
Now I pity the people who need to see this at home.
Okay. This is all equal to that.
Okay.
They just like said. Get out, they didn't know what happened. Russians had what? Think about that next time.
Trying not to inject lead into me next time.
Don't shoot a lead.
That's not even.
Well, yes, yes. I think you blew a constant. I'm just kidding.
Jack, that's not funny.
That's what I thought.
It's not a good joke. I was off by like a scale, like a factor of 5, pretty sure.
Still going.
You got the fives.
Super. Very good, very good. So if you can master this type, you can do anything. Especially getting all the numbers right.
That looks
The real
crazy.
tricky part is matching your brackets with your parentheses.
I wouldn't miss anything.
So you gotta recognize when you get circular, it kind of happened right here in between the substitution. You got the original problem back. And so there's one of those over here and 4/25 of them there. And so, and it's a minus 4/25. So when you add 4/25 to 1, 25/25 plus 4/25 give you 29/25. And then you divide that out and you get that integral back. Okay. A long, long time ago, back when I taught like regular calc, students would never get this one right, never, ever. They'd all get like different numbers. I'd have 25 people, there'd be 25 different numbers in there.
There'd be a 17 in there for some reason.
It'd be incredible.
Just 2.
Yeah, somebody gives up and writes 2.
They're equivalent, I promise. It all works out.
So I think the next 2 are just your basic partial fraction decomposition.
So we don't need to do those, right?
I'm just gonna give you the solutions and you can compare them later. Number 13, you just regular old partial fractions, -1/2 natural log of x plus 1 plus 5/2 natural log of x plus 5. Number 14, you get the natural log of x plus 3 plus 4/x plus 3. So that just had a repeated factor rule. And then number 15, I think I did by completing the square. You complete the square on that one, you get a known integral. This is an arctan integral.
Today.
Try that one by completing the square. 16, I think you complete the square and then do a trig substitution. So the subtle difference between 15 and 16 was the square root sign. So 16, complete the square, then do a trig substitution, and you should get the natural log of the square root of x plus 3 squared plus 5 over the square root of 5. So it looks like you're going to be integrating a secant, right? And then x plus 3 over the square root of 5 plus c. So it's kind of a combination of the problem above. 17, let's see. What's the plan on 17? Anybody do number 17?
Oh, it's just a.
Almost a UDU, or is it a UDU?
Yeah. Oh, no.
Almost.
It's almost.
Yeah, the
U is x squared plus 6x plus 14, so du is going to be 2x plus 6, and we have 2x plus 3. So you can add a 3 and subtract a 3 and split it up as a UDU integral, and then the completing the square integral to give you the arctan integral. So 17 will have this answer. So those three problems kind of build slowly from one to the other. Natural log of x plus 3 squared plus 5. So seeing this x plus 3 squared in here tells me I must have completed the square to do this. And the arctangent would be the other integral, minus 3 over root 5, arctan of the x plus 3 over square root of 5. Constant of integration.
Can you put the plus C like at the very beginning just to
Sure.
like mess with people?
You can,
What about like in the dead middle?
put it in the middle, hide it,
Natural log. of x plus
You've
three
given-
write it backwards.
So plus
Change it to like a J or something.
minus negative.
change to K plus constant with a K.
All right, who did number 18?
I did 18 straight.
18 was what? What'd you do?
What did I do?
What do you do?
What did you do in number 18?
Okay.
Oh, it was
UDU
the,
substitution where U is what?
that's not J,
Cosine.
that's not 18, that's
So
19.
just leave the squared behind. If U is cosine, he used the sine with a minus. And you got an arctangent integral. You get a U squared plus 9 on the bottom. So you can make that look like an arctan integral. Integral of 1 over U squared plus 9. And so you'll get, as your answer, minus from the substitution, the arctangent of the cosine of x over 3. Number 19 was repeated integration by parts, so you could do that in table form.
Yeah.
And it has a real long answer that will never fit right here. Let me start it back here, and it'll still swirl around. Let's see, you get negative 1/2 x to the 4th cosine of 2x plus x cubed sine of 2x minus 3/2, nope, sorry, plus 3/2 x squared cosine of 2x. Now it's minus 3/2 x sine of 2x minus 3/4 cosine of 2x plus c. So if you don't do this in table form, it's going to take 4 integration by partses. Then the next one, number 20, is a UDU substitution. Take U to be the stuff inside the parentheses so that you're going to integrate the sine of U, and you'll get negative 1/2 the cosine of U, where U was the natural log of 3x. 21 and 22 are your run-of-the-mill partial fractions, except for 22, you have to divide first. So number 21 is minus 2 times the natural log of x plus 6 times the natural log of x minus 1 plus c. 22, divide first, then do partial fractions. You get x squared minus x out front, minus 2/3 natural log of 3x minus 2. Actually, I don't think you do partial fractions. You just divide first. Make 3 integrals out of that. All good?
Can you go over the ones you would say to do first, like the easy ones? Like, can you pick?
The ones that I picked out was easy, like the UDU ones. 1, 2, 3, 6, 7, 11. $18.
What's my answer?
Those are all the UDU ones.
Let you know that the J's work.
Okay.
That's correct.
All right, I'm gonna do an integral and you're gonna follow along. What integral I wanna do?
Starting a new section, or are we?
This is a new section.
7.6.
No, we skipped 7.6. 7.6 is an introduction to differential equations, and you've got a whole class on that. So why do it? Why do it in one section? Okay, so I'm gonna rip some of this stuff off.
And these answers are all available online, correct?
These are all, I do have the answers posted online, yes. So that's to encourage you to please try them on your own.
For the exam, will there be this many questions on it?
Does that mean I have to grade that many?
So if we practice this and could do it in like 15 minutes, that would mean it'd be down to exam in like
Easy.
10 minutes.
So this is emphasis on doing it in 15 minutes.
this is
7.6.
Well, right now, you're just gonna integrate with me. Let's see, if I integrate u to the minus 2, I get minus u to the minus 1. And so I get minus 1 over 1. And then minus, put a 0 in there, and I get a 1/2. Am I okay on that one?
Right.
It looks right?
It's like so easy.
Holy smoke! How could that be right? This is a positive function
Wait.
above the x-axis, right? It's squared, so it's positive. I got something that's strictly positive. It's a hyperbola. And I got negative area. What the what? How could you integrate a positive function and get negative area?
You done goofed?
Where? You said I did okay.
You could just flip the sign and pretend that.
This is where domains-
that's up.
You didn't tell me what's
Something about
wrong.
dividing by 0.
What's wrong?
The second.
How does this positive function, 1 over x squared, look something like that? It's above the x-axis.
Because that x equals 2 is not defined.
That's right. We can't apply the fundamental theorem of calculus to a function that's not continuous over the interval. Because if you do, all the steps are about the same, and you get rubbish at the end. I can't bound a negative area under a positive function. So that's what's wrong. I can't do any of the steps that I did because this function is not continuous on the interval from 0 to 3. What happens at x is equal to 2?
There's a hole.
Not just a hole,
Asymptote.
there's a big old asymptote in there. So half of the graph is hugging that line upstairs and the other half isn't. So that is going to be called an improper integral. An improper integral is a definite integral. This is an improper integral of type 2. Why do type 2 first? Because it's more fun.
How many types are there?
2.
Oh, okay, cool. I thought there was gonna be like a whole.
So
quiz,
is type 1 just without a power
No, the type 1 will be if
or removable?
any of these are infinite.
Oh, okay.
Sometimes it's backwards.
So if a function is not continuous on the closed interval, you can't just integrate it and pretend that it is, and then evaluate it at the bounds, right? We can't get negative area under a positive function. So this is section 7.8, right? 7.5, 7.6, this is 7.7. Improper integrals.
We were at 7.5. Everything. And then we skipped 7.6, so it's 7.7.
So when we define a definite integral, of f on the closed interval from a to b, we wrote it like this. And we got its antiderivative and evaluated at b and then evaluated at a. But there was a disclaimer in here about f, that f had to be continuous over the entire interval from A to B, including the two endpoints, and it had to have an antiderivative of capital F. So F must be continuous on the interval from A to B with antiderivative capital F. So we're blowing that here. F is not continuous. You can't just apply the fundamental theorem of calculus, which is what this is.
So do you just exclude the,
Let's look at the graph. Let's graph f of x is 1 over x minus 2 squared. So we know when x is 2, I have an asymptote. When x is 0, I have 1/4. So 0, 1/4. When x is 1, I'm at 1. And the rest of the graph does this. When x is 3, I'm at 1, right? And say when x is 2.5, I'm getting big. So it's doing this. So we found that area to be a negative number. Right? Nothing's above below the x-axis. So it's not. Well, you got to look out for that. Some functions will have a discontinuity in them and bound a finite area. Some won't. This is an example of one that won't. Cause, let's see.
if it's removable discontinuity, it doesn't matter for us.
Yeah, we can always take care of a point discontinuity by integrating, over
We can just simplify.
subsets. So this is an improper integral of type 2, in which the function in here has a discontinuity either at x is A, at x is B, or at some point in between. But just because it's improper doesn't mean that it becomes infinite or has no value. There are improper integrals that have a value. And here's what we're going to do. We're going to break this integral up into two pieces. I'm going to integrate to this point. I'm going to integrate from 0 to say A, and then I'm going to integrate from B to 3. And then I'm going to get a function of A and a function of B, and I'm going to take the limit as A goes to 2 from the left, and I'm going to take the limit as B goes to 2 from the right. Neither of those limits are going to exist, or maybe one or both are not going to exist, and that then we'll claim that this integral diverges. But if the integral attains a value, then the integral will converge to that value. Here's an integral that converges. It has the same discontinuity. This has a discontinuity at the same place, but this integral will converge. to a finite value. That one's not gonna, and I'm gonna do them both the same way. And it's just a subtle change in the power that I put on the x minus 2. So I'm gonna do this one first, and then you can kind of visualize what's gonna happen to the other one. So I'm gonna do this integral as the integral from 0 to 2 plus the integral from 2 to 3. And here I'm going to replace this 2 with a letter and that 2 with a letter and write a limit out in front. Then make a definite integral out of them. So I'm going to put, say, from 0 to b here and take the limit as b goes to 2. And then I'm going to put an a down here. I need room for my limit. As a goes to 2 and a to 3. But these are one-sided limits. I'm breaking it up again around the interval from 0 to 3. So I'm putting the b right here and the a right there. So b is going to 2 from the left-hand side. Left, by the way, put on the 2. B goes to 2 from the left-hand side. A is coming in from the right-hand side. Now, both of those integrals are proper definite integrals. We're going to integrate them as u to the minus 1/2 du. Where u is going to be x minus 2, du is dx. What do you get when you integrate u to the negative 1/2?
1/2 squared to u,
About 2 times the square root of u.
2 times square to u.
2 times the square root of u?
Yes.
So here we get 2 times the square root of x minus 2 to be evaluated from 0 to b. And once we do that, we take the limit as b goes to 2 from the left. And get the same thing here. A is going to go to 2 from the right. We're going to get 2 times the square root of x minus 2 to be evaluated from a to 3. So here in this first one, b goes to 2 from the left, and I get 2 times the square root of b minus 2. Oh crap, I should have made that. I get a negative number to the radical sign. I screwed it up. I don't want that. Err. That's not even defined on this side. That's really improper. I didn't mean for that to happen. Crud. Well, I screwed it up and class is over. All right, this is not even defined. Fudge.
Well, let's do it anyway. Let's compute it and see what happens.
We can break out all
I
the
saw it
big
at the
letters
beginning,
like
I was
that.
like-
I was like,
Yeah.
yay.
All right, I'll fix that next time.
All right, so we'll just leave it at minus.
No, I lied. That one will not converge. First Howard, I think it'll converge.
72.
Everybody should come today to the honors third floor lounge and get free cookies and draw a dog for one of my projects. That's
And
all you do. It's cookies
practice that.
and you draw a dog. That's it.
What time?
When is it?
So you want to see if
1:30
they
to
draw
3
big dogs or little dogs?
3:30 today.
Oh, you
So just show up, draw a dog, and get
It
cookies.
was 9.
Okay, I got Latin. I was like,
I really good at it.
Beautiful. Now all you have to do is submit a form for me. I mean, your choice of a marker wouldn't work for the questions, but amazing.
I don't really. They got filthy glue. See.